Welcome, everyone. Thanks for joining us today. This is the third in our series of 5 Friday afternoon workshops in the fall here. It's now officially fall that are dedicated to presenting student activities for exploring statistical concepts. Today's presenter will be Laura Callis. Laura teaches statistics and other things related to math and math education at Curry College, which is just south of Boston. Laura will be presenting an activity today designed to introduce students to the idea of comparing two proportions between two groups. So thanks to everyone for joining us. Thanks especially to Laura for presenting today. And I'll ask Laura to take it away.
Okay, so I'm going to use Desmos Activity Builder because I know we've gotten feedback in the past that sometimes it feels like we're going really fast, and I think that's true of all of us who are teaching. We feel like we're going at a normal pace, but for folks who are taking it in, it can feel really fast. And on Desmos, I'll be able to see what you're writing, and that way I'll be able to see, is it time to move on, or do people still need a minute because they're writing down some thoughts? So let me put that link in the chat. Just takes me a minute to copy. Okay, so there's a link in the chat. You can go to student.desmos.com and enter in the number 7R2HYB if you can't get to the chat. Let me share my screen. And if you're already there, there we go. If you're already there, we're going to be talking about comparing two proportions today. And so what are some scenarios or studies or ideas for studies that you might have where you would have to compare two proportions because you're looking for an association between two variables? I have a couple that are posted and up to get our juices flowing that I use with my students. So our applications to use the Hubble Space Telescope from men, PI is disproportionately more likely to be accepted than applications from women. Our resumes sent out with names common in African American communities more likely to be selected for an interview than identical resumes with names common in white communities. There might be other things that you can think of too. So if you could put down some ideas here so that we can have lots of ideas to share, and then that will also help me make sure I'm seeing what folks, that it's going through to Desmos and I can see what you're saying.
One question, just to make sure we're on the same page. If someone's new to Desmos, they should just click continue without signing in. Is that correct?
Yeah, they can. If you sign in, it will save everything that you write and it will save any notes that I write you. And if you don't sign in, you will still have access to these, but it won't remember anything that you've done.
Thank you.
So I recommend signing in, but you don't have to. You can also sign in with Google. Nice. Okay, seeing lots of folks join us. That's great. Does one teaching method yield better results? Yeah, so one person is saying, well, more men are accepted because more men apply for the Hubble Space Telescope one. And that's why we have to talk about proportions, right? We're not just comparing the number, but if we look at the proportion of applications where men are the PI that are accepted compared to the proportion of applications where women are the PI and accepted, then we have something that we can compare against. Presence and absence of disease with a vaccine. Proportion of upper class students taking stats compared to first years and sophomores. Depression, having depression, and it just moved. I lost that one. Lots of different ideas. Great, thank you. Super. So if you hop on over to the next slide, slide 2, this is what we're talking about today. So our goal is just to try out the beginning of an in-class activity that's about comparing two proportions. You can access this activity at the STUB website, Statistical Thinking in Undergraduate Biology, on CAUSEWeb. It's Exploration 5.2. There's a ton more questions there that we're not going to have time to go through. It usually takes me 75 minutes or more, and we only have an hour today. And I also know from feedback from participants that you want some time to try out the applets and things like that. So we won't have time to go through all the questions, but if you have questions about the questions, you can email any of us. I think that this activity really aligns to 5 of the recommendations from CASE. We're talking about statistical thinking because we're looking at the statistical investigation process and going through that. We're focusing on conceptual understanding. We're integrating real data with context and purpose, and we're going to foster active learning. We're going to use technology to explore concepts and analyze data. So I think that it's a great activity to start with if you are beginning to look at the CASE recommendations. So this is the statistical, oh, was that, I heard someone. Okay.
We have a question in the chat or a comment that the stub link is not working. That's because Cause is working to renew their security certificate. If you want to go there, despite the warning it gives you, you can find it fine, but you do have to make your way through the security warnings. And the people at Cause have assured me there's no real security threat for people that go to the site.
And we do have on the EA Post website, we do have the full exploration posted there too. And I know that they are working on it, so should be up soon. So this is a statistical investigation cycle. Ask a research question, design a study and collect data, explore the data even before we do any kind of inferential tests, then draw inferences, formulate conclusions, and look back and ahead. We're going to go through steps 1 through 5. We're going to skip step 6 so that there's time to sort of play with the different applets and talk in groups. So this is our research question. Past research has shown that when a person making a request touches the person that they're talking to, that person is more likely to comply with the request. And so as AI and robots become a larger and larger part of our lives, these researchers were wondering, well, is that true for robots when they make a request and they touch the person they're requesting? And this is a real research study that you can look up and have your students read if you're having them practice analyzing research studies in your course. And this is the design of the study. So I'm over on slide 5 for folks who are following along. I'll give a second so folks can join us there. So over on slide 5, some details about the study. They had 42 students at a European university. All of the students had their hand attached to a box, and this, they said, was to measure skin conductance level. Really, the researchers needed their hand to be available for a robot touch, but of course they wanted that experience to be the same for those participants that would be touched by the robot and those that weren't. All of the students listened to the robot's request to take business English, and then the students were randomly assigned to receive touches by the robot during the request or to not receive touches. And then after, they asked the students if they were going to take the business English class, were they going to, comply with the request? So we always kind of want to unpack the study design with students when we're looking through some data, because that's probably one of the most important parts. So to you, is this an observational study or an experiment? And why do you think that the researchers randomly assign the participants to receive a touch or not? So you can click on one of these and a box will open up and you can write some thoughts about why did they randomly assign the participants to receive a touch or not. So if you can put in some thoughts over on slide 5, that would be great. And I'll take a look at what folks are saying to make sure I'm not going too fast as well. I've got 10 folks. Oh, still going up. 12 folks who said something. All right. So we're over on slide 5. Yeah, I agree. It's an experiment. We've got a control group and a experimental group, and we're kind of comparing the results, right? There's random assignment too. And a lot of folks are saying like, oh, well, if you have random assignment, you're probably going to avoid having some confounding variables imbalanced in one of the groups or the other. So if we only take the first 21 students who come and make sure that the robot touches them, we might be introducing something like, being on time might actually have something to do with compliance or something like that, right? So we're going to talk about writing hypotheses. So we have these two ideas that either robot touch does increase compliance or robot touch doesn't increase compliance. And this is over on slide 6. We're going to let pi sub bot represent the long run proportion of times that people who were touched by a robot would comply with this request. This is kind of a theoretical proportion that we're wondering, everybody in the world did this over and over and over again, what proportion of people would comply with their request if they were touched by a robot? And then pi sub no robot represents the long run proportion of times that people who are not touched by a robot would comply with this request. So they're both about complying. We're just looking at two different groups. So over on the next page, determine which is the null and alternative hypothesis. Usually at this stage, we're about, after midterms. So we've done a lot of null and alternative hypotheses with single variables, and now we're looking at two variables. And how would you write them with symbols? So if you go over to slide 7, this is called a card sort slide. And we're going to make two groups. One group is going to be about the alternative hypothesis, and the other group is going to be about the null hypothesis. And the way that this slide works is that if you click and hold and drag, you can get it really close to one of the cards you want it attached to. And if you let it go, it will group them, and I will be able to see what you're doing. So over on my slide, I can see everybody that's getting it right and that's getting it wrong. And then I can click on an individual student and see how are they getting it wrong, what particular cards do they have mixed up. But if you just put them close to each other, I can't see that. So make sure that you see it light up and let go so that they're really connected. So I'll give folks a chance to, on slide 7, play with that slide and see what do people think about how do you write the null and alternative hypotheses. So this is slide 7. Give folks a little bit of time. I still see cards moving around. Okay, so it looks like the cards have slowed down. So I want to, oh, neat. I want to show you what I see. So I'm going to share a different screen. Hope this works. Okay. So if I go to summary, I can see all of the students who have done it correctly, and I can see students who are kind of in the process, and I can see students who haven't gotten it right. I can also see students who aren't there, so they're over here on the slide. I can also see that with these little numbers and hover over them and see who's there. And in class, what I do is I use that information to go visit a student because something's going on. They're not sure what's happening. Or I might repeat myself like, oh, go over to slide 7. I can also on this page, see how people are doing. And if I click show correctness, I can see some people are still thinking. I can anonymize this if people are embarrassed, and it turns it into mathematicians' names. The blue means that they're getting things right. The orange means that they're not getting things right and which ones aren't right. And so I can zoom in to see like, what's going on? What don't they have right? And clicking on this tool helps me to see what they have mixed up. And I usually will use this little note right here to tell them, oh, you've got the idea right, but actually you have the vocabulary where it's wrong or something like that to help them. This also helps me to make really quick groups because I can say, Wang, Junji, will you please talk with Jesse? Because then they can discuss how things are different. Okay, so I'm going to stop sharing and then share my other screen so that mine looks like yours. All right, so it seems like most folks agree that robot touch does not increase compliance as our null hypothesis, and robot touch increases compliance as our alternative. And there's a couple of different ways that we could write that. If it does not increase compliance, then the proportion of people who complied when they were touched by the robot is going to be the same as the proportion of people who complied when they were not touched by the robot. So those two proportions in the long run would be equal. And if robot touch increases compliance, then we would expect the people who were touched by the robot to have a higher rate of compliance in the long run. And then these are a little bit, we have to talk about these usually in class. In this case, we're saying, well, if they are the same, those two proportions are the same in the long run, then if you subtracted them, if you found the difference, there would be no difference between them. And if there was a difference, we're going to subtract the robot touch from the people who complied without the robot touch. And we would think that if robot touch increases the rate of compliance, then we would end up with a positive number. So we sometimes have to unpack that a little bit in class. Nice. All right, so let's explore the data. That's the third step in our process. So over on slide 3, come join me. In this study, 21 students were in each group. 17 of the 21 students in the group that received the touch complied with the request. They said, yeah, I'll take business English. And 10 of the students in the no touch group complied with the request. So in my classes, sometimes we have to unpack how do you read a two-way table. So go ahead and put those numbers in. Where should those numbers go? So 17 students were complying in the robot touch group. How many in the non-robot touch group were complying? How many did not comply? And then what are those totals? So I'll give you a minute to do that. It kind of helps students to make sense of the numbers. And then once I see that folks have done that, we can keep moving. And this is helping me to make sure I'm not going too fast because I can see how fast people are filling in that chart. All right. And it looks like everybody's getting it right, but I would probably meet with a student if I was seeing something happening. And I've got the results up there too. Okay. All right. So over on slide 9, Tamara earlier had made a really important point that, well, we have to compare kind of like groups in order for us to be able to make any kind of claims. And maybe, you know, her point was that maybe more men apply than women. And so really what we want to be looking at is proportions. So even though we have same size groups here, we're still going to be looking at proportions since that's the statistic that we're usually going to be using. So fill out the chart just so I can see that you're following along. What proportion of the robot touch group complied? What proportion of the no touch group complied? What's the difference between those two proportions? And looking at that, is there some evidence that robot touch increases compliance? You can write that answer here. The really nice thing about Desmos is it will do math for you. So I have a lot of students that struggle with numeracy. But if they know how to do it, then the kind of calculations or the calculator strokes are kind of less of a big deal. And so they could type in, oh, well, there's 17 people in the robot touch group who complied, and there's 21 people total, and it will calculate it for them. They can also use this calculator up here, and this calculator knows how to do order of operations. So if they're thinking, well, there were 17 people out of 21 in the comply group, and there were how many? There were 10 in the non-robot touch that complied. And see, it knows order of operations, which is really nice. So I'll give you a minute over on slide 9 to fill in that table and tell me, what do you think about evidence, whether there's evidence that robot touch increases compliance? And thanks for continuing to fill it in. That helps me know if I'm going too fast to see where folks are at. Okay. All right. So it looks like folks, are doing a beautiful job. There were 10 people complying, 10 students complying who were in the non-robot touch group out of 21. So that's about 47%. The difference between those two is about 33%. Yes. And so it seems like looking here that maybe there's a little bit of evidence that the robot touch is increasing the rate of compliance, right? The 17 is higher than the 10. The 17 out of 21 is a higher proportion than the 10 out of 21. So we're not really sure yet. Maybe that's too small of a difference. Maybe that's just due to chance. And that's what we're going to investigate next. So I want to show you how to use some of these applets. So over on slide 10, there's a link to the applet, and I'll show you how to use it. I'm also going to put the link in the chat in case that's easier for folks. And my chat, where'd it go? So I put the link to the applet in the chat, but it's also linked on Desmos on slide 10. So that one. All right, so on the applet, you're going to click on the box in the top left that says Enter Table and click on it. And you can edit these headers to represent the particular study that you're looking at. So here we want group A to be folks in the robot touch group. And maybe I'll just put touch so it fits nicer, but you can put robot touch and no touch in the other group. And then the success is students complying with the robot's request to take business English, and then the failures would be not complying. And I spelled that wrong. And then we'll fill in the values just like you did on the Desmos slide. And what's nice is it does the addition for you. And then you're going to click Use Table to get it to graph the data. So I click Use Table. And you can change it. This is a regular bar graph. You can change it to a mosaic plot. And what's nice about that is the widths, the relative widths will tell you about the different sample sizes. So for instance, if we were looking at the applications of men and women to use the Hubble Space Telescope, these widths would be different. Our size groups, our groups are the same size, and so they are the same width. And so just looking at this, I can see, oh, for the people who were in the robot touch group, they had a higher rate of compliance than people in the no touch group. And we can see how big of a difference that is visually by looking at the difference between those two heights. Okay. So looking at the graph, how do you see whether there might be an association between robot touch and compliance? What would you expect to see if there was no association? So if you could tell me like even a sentence down here, that would be helpful so I can see what folks are thinking. And if you need help, you can also write help and I can go back over things because I can see what you're writing. So I'll give folks a minute to write on slide 10 so that I know that you can see what we're looking at. I can tell that some people are still writing. So I'm just going to give them a minute. There's some really good things that I want to share though. So a lot of folks are saying that if there was no association, we would expect the height of these two compliance towers to be the same. It's not that it has to be 50%, but whatever the line is would be the same on both sides. I think that's really worth bringing up because students might think that everything has to be equal. It seems to be something that they think all the time, when really we just want the rates to be the same in the two groups if we think that there's no association. Nice. Great. So over on slide 11, we are going to start talking about inferences, and in a bit, you'll be able to work in groups to sort of play and think this out. So the proportion of people in the touch group who complied was 33% higher than the proportion of people in the no touch group, the compliance rate. We use percents and decimals a lot in my class because I have students who feel much more comfortable with percents, so sometimes we'll bounce back and forth. So this seems like the robot touch matters, right? It seems like robot touch increases compliance. And that could be true. But it also could be true that students who were going to comply were going to comply anyway, regardless of which group they were assigned to. They were just, are very interested in business English, or they're very not interested in business English. The robot touch really doesn't matter. Maybe by chance, students who are going to comply anyway just happen to be randomly assigned to the robot touch group at a higher rate. So we're going to simulate the second idea, this like null hypothesis idea. So this is a picture. If you want to go back through these slides sometime, there's a video of me doing a simulation, and sometimes I do that for my asynchronous online classes so they get the idea. And what we would do, it's like 6 minutes long. What we would do is we would have a card for each person. So one card represents one person. And because we're assuming that the person's either going to comply or they're not going to comply, it's just like intrinsic to them, we would write that they would not comply on the card, or we would write that they'd comply. I'm using the same colors as the app that will come up later. And if we think that, well, it might just be random assignment that resulted in more of the people who were going to comply being in the robot group, we could simulate that by shuffling these cards up really well and then dealing them into two groups. One group will be the robot touch group, and the other group will be the no robot touch group. And so I could put them into two piles. And then after I do that, all the cards are used up. I have two equal groups. I would look in each pile to see how many compliers I have and what proportion of that group are compliers. And then I would do the same thing in the other group. What proportion of those guys are compliers? And then I would find the difference in those proportions. So you probably don't have cards, so I'm going to show you a couple of applet or tools, online tools you could use to sort of simulate cards. Or if you're teaching an online class, maybe you just have a video, or maybe you have a printout and they're supposed to cut up the cards and deal them out themselves. I've done that before too. So over on slide 13, I have links to some tools, and I'm going to talk to you about like the benefits and drawbacks of each, and the links are the underlined bits. So in the CPM probability tools, you can open up that in a new link. You can drag over a bag, and the applet that we're going to use uses blue and green. It uses blue to represent the compliers. And we have 27 total compliers. So I'm going to change that to 27. And I'm going to click on this square and choose blue so that it's more similar to the applet we'll be moving to. And then I'm going to add a new item. I'm going to add a green circle. I'm using circles because sometimes students have color difficulties and they look the same to them. And there were 15 people who didn't comply. And then this is important. Make sure that you click off with replacement, because we really want to simulate what's actually happening in the study. The students are being randomly assigned to one group. They're not being randomly assigned and then put back and then randomly assigned again, right? So once we take that block out of the bag, it's done. It's already in one of our two groups. You can choose to draw items one at a time. I like to do that because I think it helps students think about what they're actually looking at. But once students get good, you might want to say, okay, just tell me the first 21 that are pulled out. Those guys are going to be the robot group, the robot touch group. And then you can click on the bag and it'll shake it up and it'll give you the 21 items. So it looks like I only had 1, 2, 3, 4, 5, 6 non-compliers in my robot touch group. And then you can click on it again and it will bring up a new string. It'll attach them, so you just have to be careful that students know where one string ends and the other begins. See, it attaches it and it can be a little bit messy. And that might be another reason why you want to draw one out at a time. The other applet, so one of the things we find sometimes at Curry is that students' ability to keep track of multiple different abstract things can be tough. And we just made it a little bit abstract, right? I had these cards, and now I'm asking you to remember, oh, blue represents this, green represents this. We're taking 21 because of this. So it might be easier for some students to use this card shuffler if they don't have actual physical cards at home. And with this virtual card deck, each line represents one card that you're going to draw. So person 1 is a complier, and person 2 is a complier. I really recommend putting down the numbers so that you can tell when a new card is drawn. And I'm going to do that all the way until I get to row 27 to represent the 27 people who were compliers. And then 28 is a non-complier. They did not want to take business English. 29, also non-complier. All the way until I get to person 42. And then you click go, and you click draw a card, and it will bring up one card at a time, but you won't see the other cards it's already drawn. So in this case, students have to keep a kind of tally of which cards they've got. It's still doing it without replacement, but we won't really know like when we have drawn 21 cards. So if we click draw, oops, the first card is person 2, they're a complier. I'm going to write that down. The next person in my robot group is a non-complier, number 28. And I'll keep doing that, keep a tally until I get 21 people for my robot group, robot touch group. Okay. So we are going to work in groups. You can try out one of those 2 ideas in your group. We're trying to find the proportion of people who complied in the robot touch group and the proportion of people who didn't comply in the robot touch group. And then we're looking for that difference, remembering that we want the first number in our subtraction to be the robot group. So then once you get that number, everybody in your group will get their own number from doing a simulation. Over on the next slide, tell me where your number is, where your number falls, your difference in the percentages. That's going to help us create a graph so we can see, well, what tends to happen. Okay. So we're going to be working on slides 13 and 14 in groups. You can choose whichever tool you want. Hi. Welcome back. So that's a workaround if you need to do a simulation, but you're, for whatever reason, you have to be on Zoom. Although I really feel like cards and tactile things work best. And we're going to show you an applet in a minute, but I've found in my classes, I have to do the real thing in order for them to understand the applet. So it looks like for most folks, we were kind of in this area, very, very little difference, right? Which should make sense. If we are assuming that there's no real difference, that they were just kind of randomly assigned and just by random chance, we ended up with more compliers in one group, and we're assuming there's no difference, then that's what we would expect to see most often. So we're assuming that null hypothesis is true. But weird things do happen, right? Some folks got this number that's a little bit more than we would expect, although nobody got anything that's what we actually got in the real study, right? Nobody got a difference that was that big. But we're only maybe 60 people or something here. And so what we really want to do is do this a bunch of times, way more than just 60 times. So over on slide 15, we're going to use the applet. I'll put it's the same applet link, but I'll put the link again in the chat, but it's the same one. And this is going to allow us to do lots and lots and lots of repetitions. And again, we're going to have a chance to work in small groups to play with it and talk about what we see. So in the applet, you're going to click on Show Shuffle Options. So it's that box that's on the right, and it's going to open up a whole bunch of new options. I always start with just doing one with students, and we do quite a few single shuffles so that we can really talk about what's going on. I also click to the cards, which is going to put these little people. So what we're looking at, group A is going to be the touch group. It's going to be whatever the first variable is over here on the left. Group B is going to be the no touch group. The blue, just like I did with the CPM applet and how I color my cards, the blue are going to be people who complied, and the green are going to be the people who aren't complying. And so if I click shuffle, I see what's happening is I'm mixing them all up, and they get randomly dealt into group A or group B, the robot touch group and the non-touch group. The blue are still the people who are complying, and the green are still the non-compliers. In this case, we could see, well, if I found the proportion of people in the robot touch group who did comply, that would be 14/21. So, right, yeah. And then in the other group, it would be 13/21. So kind of close together, right? And then if I look down here, I could see, yeah, that when we find the difference between the two groups, the proportions of the two groups is very, very small. And it's plotted that over here. This dot right here is right above the 0.048. So I can do that again, shuffle. Okay, I'm looking at the robot touch group, the non-robot touch group. It turned out the same, the proportions are the same, shuffle again. In this case, it's just slightly different. In the robot touch group, it's 13/21, a little bit lower. In the non-robot touch group, it's 14/21, a little bit higher. We can see that difference in proportions is right over here. And I can do this a bunch of times. I actually do make my students do it a bunch of times and talk through each one. But eventually we're going to get carpal tunnel if we keep doing that. So I can change this to be 1,000 shuffles and click. And now I can always go back to individual shuffles to see what they look like. And so if I click here, I can see the difference between those is always the same, those particular shuffles. And I can start to quantify, well, it seems like mostly we're pretty close to zero. There doesn't seem to be much of a difference between the two groups, which should make sense because we're assuming there would be no difference between the two groups. But sometimes we do get things really far away. Like in this case, wow, those two groups are really different in terms of the percent of compliers. And over here too, those two groups are really different in terms of the percent of compliers. So what we're wondering is, well, could it be that they're really in the real world, if we made everybody do this study for a really long time, there really wouldn't be any difference between people who were touched by a robot and people who were. And it's just this random assignment that ended up putting natural compliers into the robot touch group. And we can see that, well, that does happen sometimes, but not very often. It might be a little bit hard to see on the graph how often that happens. And so you can use this count samples as, and let's put in our actual observed statistic, that difference between the two proportions, and see how often that happens just due to random chance. For me, it happened 20 out of 1,000 times. So not very common, but still possible. Over on, yeah, so what we're going to do is in our groups, you're going to play with that, try it, talk about what you see, maybe share one person's screen. And then over on slide 16, which of these do you think is true based off of what you saw in your groups? And there will be folks in your groups to help you navigate the applet and talk about what you're looking at. So can we go back into groups?
Yeah, do you want to specify 5 minutes or what do you think?
Yeah, I think 7 was good. I hope other folks thought 7 was good.
That's going to
You know,
take us till 3 minutes till the top of the hour. Why don't we try
okay,
to do it in 5?
5 minutes. So we got over on slide 5, folks were kind of saying different things, which I think could be true, right? So most folks were saying we really got a difference in proportions as extreme as our actual study when we were simulating the null hypothesis. So we think that there is a real difference between people's tendency to comply if they receive a robot touch. We don't think the null hypothesis is true because if it was, our results would be so rare. But some people were saying that like, well, it really, depends on your significance level. Like, it was rare, but it wasn't that rare. Like if we do some more shuffles, and even if we do like a two-tailed test or something, like this isn't like non-existent, right? It could still be due to chance, and I think that that's the uncomfortable space that statistics lives in, is like we can never be 100% sure. It's not pure mathematics where we can just prove things. So thank you so much for hanging out today. Please feel free to reach out to me. These slides are available if you want to go back to any of the links. Next week, join us for Jill's talk on analyzing paired data. And then shameless plug, I have a chapter that has some activities in it that might be useful for your introductory statistics classes. You can get that link there. It's a free book. And let me know what you think if you read it. Otherwise, I can answer questions or we can have a discussion. See if there's comments in the chat. Oh, there was one question about you only having data or plots on the applet. So you have to make sure that you use the two-way table in order to get the little people that shuffle. So if you click on, change the two-way table to actually have your own data instead of just a list over on the left-hand side. I can model that if folks want to see that. If there's, yes, I can post the link to the book. So this is the whole book. And I'm the only chapter on statistics, so you can just Control F for statistics or Control F for my name.
Very much, Laura. Questions, comments, reactions?